Welcome to our final video in the mini-series on problem-solving strategies for problems involving conversion factors between mass, moles, and molecules. In this final video, we're going to look at a particularly challenging problem that's going to require us to do a multi-step conversion and require us to use some of our prior knowledge involving units. In this problem, we are told that taste receptor proteins, the little proteins on your tongue that respond to the molecules that are in the food that you eat, can detect as little as 20.0 micrograms of a molecule called capsaicin. Capsaicin is a molecule that has a chemical formula C18H27NO3, and this molecule is responsible for the hot, spicy flavor of wasabi or hot peppers. And what we are asked to do here is to determine how many molecules of capsaicin are required for the tongue to detect this, right? So basically, we need to set up a problem that allows us, or a pathway rather, that allows us to start off with a given mass given to us in micrograms and ultimately convert that microgram quantity of capsaicin into number of individual capsaicin molecules. So proceeding as we did in the previous videos, we're going to start off with our initial process of writing out the basic set of unit conversions we're going to need without actually doing the mathematics. So starting off, we see that we have a given quantity that's given to us in micrograms. So writing out micrograms as our starting point, we now need to ask the question, do any of our conversion factors deal with microgram quantities? Well, our molar mass, remember, is given to us in grams per mole. So if we are going to apply our molar mass, as we will have to in a bit, we're going to first need to convert this microgram quantity into grams. Once we have grams, then we can use our molar mass to get to moles of capsaicin. Once we have moles of capsaicin, we can then use Avogadro's number to get to the number of molecules. So let's go through here and write out what those conversion factors are actually going to be. Well, again, going back to our prior knowledge, what you guys recall regarding the prefixes for our metric system conversions, if you're given a microgram quantity, we know that there are actually 10 to the 6 micrograms in 1 gram. So we're going to need to apply that conversion factor as our first step. Then we're going to need to use the molar mass of capsaicin. Now remember, capsaicin is a relatively large molecule, but we're going to use the same sort of approach we did previously, going back to that periodic table, looking at the molar mass of carbon, multiplying by 18, adding to that the molar mass of hydrogen, multiplied by 27, so on and so forth. And at the end of the day, you should find a molar mass for this guy that's roughly, so 1 mole of capsaicin here, and I'm going to, for the sake of space here, not write out the full chemical formula just yet, but it should come out to something on the order of 305.4 grams. Okay, so the molar mass of capsaicin here, again, it's C18H27NO3. And then finally, our conversion factor to go from moles to number of individual atoms or molecules is going to be our good friend Avogadro's number, 6.022 times 10 to the 23rd. Okay, now that we have this laid out, we're going to start from the very beginning and plug in the actual numerical values that we're given. So the first step for our final solution, start off with that microgram quantity that the problem gives us. 20.0 micrograms of capsaicin. Now, I know it's a bit painful here, but I want to go ahead and write out that full chemical formula, that full identity of the molecule with every one of these units, because it helps us keep our thinking straight and will ultimately allow us to expedite the problem-solving process, but also find errors, if they come up. So starting off with the microgram quantity here, we are then going to carry out a conversion that takes us from micrograms to grams using the fact that there are 10 to the 6th micrograms in 1 gram. So this conversion factor will now cancel out my microgram units and replace it with grams. So at this point, dividing by 10 to the 6th, we are going to have the number of grams of capsaicin required to activate this protein receptor. Then our next step is to use this molar mass. Now the molar mass we calculated in the previous step tells us that in 1 mole of our capsaicin, and once again, I'm going to write out the full thing, full chemical formula there, weighs approximately 305.4 grams. Okay. Now, micrograms have canceled out. Now grams have canceled out. Now we are currently in moles of capsaicin molecules. Our final step then is to use Avogadro's number as our final conversion to obtain our answer, which will then be in number of individual capsaicin molecules. So conversion factor here, okay, we are going to want to cancel out moles, so we're going to put moles in the denominator. So 1 mole of C18H27NO3, all right, contains 6.022 times 10 to the 23rd molecules of capsaicin. Now we are all set. We can now plug all these values into the calculator, and you should get a final answer on the order of 3.94 times 10 to the 16th individual molecules of capsaicin, NO3. So even though this seems like a relatively small quantity, 20 micrograms, and our taste receptors are very sensitive, as you guys will tell if you bite into a pepper or take a piece of wasabi and put it in your mouth, it still takes 10 to the 16th individual molecules to actually send that signal so that your brain registers you're eating something spicy. That's it.